as you can see, the second one is more focused on this 3D cities use case and augmented reality. So when talking about smart cities, we usually have something like this in mind. A 2D map and some POIs visualized as icons or something similar on it. But where we want to go is something like this. So that's the ultimate goal, yeah? Having a place of interest instead of a point. Having a new POI format beyond latitude and longitude pairs with a label. That's why I would like to introduce some other enablers, and we will start with the POI Data Provider GE. So points of interest, abbreviated POIs, are points, so they relate information to places. The information related to a place can be whatever you need for your application, like restaurants and scenic places for tourists, or a maintenance room for some employee. And they're within some coordinate reference system. What does a POI data provider do? So the POI system is used to store and retrieve data by location. So data retrieval arguments may include different kinds of area description and other conditions. So a useful example may be finding restaurants near to you when you're visiting a new town. Like me, I arrived yesterday late and I need something for dinner. I use Google. So there is a new FIWARE POI Data Provider, and there are already several other POI data and API definitions proposed and in use. However, it seems that there is room for one more with some special features. The FIWARE POI data definitions are developed to avoid complexity and bloated data of other POI systems. Due to the modular structure of the FIWARE POI system, the amount of data transferred from the server is kept minimal, which is a significant benefit for the mobile use cases. Using the FIWARE POI system, the architecture allows you to create your public or proprietary system on top of existing public or proprietary POI services. So your system may enhance existing POIs with your data and add your special POIs to existing selection of POIs. Of course, your specialties are visible only to the users of your system. So you can combine public available data from public POI data providers with your own instances of the POI data provider to host, for instance, application-specific data. Using the POI information on the map is a very common way to present location-dependent information. So there are several systems using this approach, like Google Maps and OpenStreetMap, which are familiar examples of this approach. But you could also, in general, if the information needs to be found by location, use it in any way your application would like to use these data. For instance, when following augmented reality approaches, you might need further application-specific, like marker you detect, or how the information is overlaid with the physical objects. So developing using the FIWARE Data Provider GE, there is not that much you need before, so there are some development prerequisites, which I will talk about now, and followed by some explanations of this modular and distributed data and the components, how multilingual content is solved or foreseen in this approach, and how to do spatial search and additional data retrieval, and the usual CRUD operations on POIs. So what you need is some basic JavaScript knowledge, as we are on the WebUI chapter in FIWARE. This is the common prerequisite. And maybe some knowledge about some of those frameworks, like the Google Maps API or the Open Layers, for instance, which is another framework to visualize maps. More information about how to develop with the POI Data Provider GE are given in the User and Programmer's Guide within the FIWARE wiki. So coming to the modular and distributed approach. So the modular data is to avoid unnecessary data transmission. And POI consists of modules for different purposes. So on the one hand, to not transmit them. On the other hand, you can store them in different locations. So like having different instances of the POI data provider, like having a public POI data provider that hosts the label and the location as longitude, latitude, which is all part of the FIWARE core component of a POI. But on the other hand, you have some media, like personal images attached to this POI that are hosted by a community-owned or your personal POI data provider, which then in turn can be merged to or fused to one POI entity. Using HTTP requests, it's defined which data components are requested. And as I said, they can be on different servers. So the transmission is done using JSON format, and each POI is identified using UUID, and is a JSON object and has several properties, which are the names of the components. So here we have one POI with the ID in red, and two components in green, which is the FIWARE core and FIWARE time component that represents opening hours of a business, for instance. There can be other components like the FIWARE media or FIWARE XML 3D to attach a 3D geometry or a 3D representation of this POI. This is the upper structure of a POI. So each component is then structured in itself, and there is a JSON schema available to validate those data. POIs are usually meant for tourists, so you need to solve this language issue. It doesn't help me if I get Spanish information on the next restaurant because I'm not familiar with the Spanish language. So for the POIs, there are multilingual data items. So some properties of the POIs, like the label, is not simply one string. Instead, it is an object that has several properties with the ISO language code as properties, and then a string in the respective language to have, for instance, several translations of this label available in one place. Moreover, there is an empty property to give a language independent name of this place, for instance. Yeah, and the example with the label is right below. To avoid the need to duplicate text for the default language, there is also another property _def, where you can refer to the default language property, which is part of this object. Of course, you can perform spatial search, like a radial search. There is one example query given here. So you pass latitude, longitude, and the radius for some circle on a sphere. And you can also filter by other properties of the POIs, like the category. And we're looking for nearby cafe or restaurant. Yeah, example code for this is available in the manual of this GE. When we now retrieve the core component of these POIs, as they were determined to be nearby, so within this radius around the position, then we can retrieve additional data by explicitly requesting a specific component of a specific POI ID. This is just a second GET request that can be done for batch POIs as well. So you can pass several POI IDs and retrieve this specific component or several components for a set of POIs. Creation is done using a post request on the add POI method of the endpoint. There you post just this JSON structure to that contains the POI data. An update is done using a post on the update POI, but before you have to retrieve the previous data of the POI and modify this and write back to ensure that no information get lost. There's also the last update property that gives information about the last modification of this POI, of the component of the POI. Deleting a POI is just done performing a delete request on the delete POI method and passing by POI ID. Yeah, so example code snippets are in the manual available. Let's see how this looks like in action. There is this one. So that's obviously Berlin, and it visualizes hotels, I guess, yeah, hotels in Berlin, and this gives the raw data that is delivered by the POI Data Provider.
So one question is, you were talking about the server assigning UUID. You were also mentioning earlier on that you can query POI data from different servers.
Mm-hmm.
But in that case, each of the servers should share the same UUID. So how does that work in practice? Or doesn't it work that way and you just query on lat long, for instance, and type of POI?
The idea is that you fuse the POI data based on this UUID as you already got. But a UUID is only created when you create a new POI. So a POI is meant to be an entity, a unique entity. And either you already have a POI, like a public one of the university here, then I can add a data component using the same UUID of this public POI on my instance to amend it with application-specific data or with my data and so on.
But so you said that when you create a POI, you get a UUID back. But do you also have the possibility then to create a POI with already pre-assigned UUID information?
Then you do not create it, you update a POI.
Okay, so you can update a non-existing POI.
You can update a POI that exists because it has a UUID, but has no data yet stored on this particular instance of the POI Data Provider. Yeah. Okay, well. So this is the usual use case we have in mind when talking about POIs, as I said in the beginning. But we want to overcome these 2D maps. Therefore, we need more sophisticated data and going for 3D. Which leads us to the GIS Data Provider GE. The GIS Data Provider GE is there because there was the need to create an infrastructure for web-based 3D GIS services. The GIS Data Provider provides this infrastructure to query and obtain georeferenced 3D models through RESTful APIs that are, these interfaces are standardized by the OGC, for instance, and there are several APIs exposed by the GeoServer, which is the core of this generic enabler. So the main features are that it supports data in XML 3D, which is the 3D UI GE we presented in the beginning of the first session. And also an Octet-stream output format, which is much more efficient than this XML based. So you can perform the usual operations like selecting different layers that are contained in this GeoServer, query for bounding box, and decide in which delivery format it is Okay, this also has LOD support and so on. The internal and external data storage is done using the GeoServer, which is an open source implementation of those standards that were made by the OGC. And it uses a Postgres and a PostGIS database. The FIWARE release support currently metric coordinate systems, so the usual ones. You can use any kind of GIS tool to import data into this GeoServer, so to make it available via the APIs towards any web application based on the 3D UI GE. The architecture, or high-level architecture, looks like this. So there is the GeoServer in the middle, there is the data storage at the bottom, and on the top in the middle there might be some front-end server that embeds, for instance, the georeference application, or the client directly talks to the GeoServer to retrieve the geospatial data. So the API looks like this. So there are 3 requests to get the capabilities of this instance, because they might differ from instance to instance depending on the configuration. There is the get scene request to retrieve 3D assets, and the get feature info to get more information on a specific feature, like a building contour and so on. So the representation format is XML3D. So when using this example request, for instance, you will retrieve a group that contains XML3D meshes and can be directly pasted into the DOM and then visualized. There's also an example available. Which is this one. So the client is just a very naive implementation, but it loads some tiles from the GIS Data Provider GE and visualizes that as high fields. So they retrieve elevation data from the GIS Data Provider GE. This elevation data can also be delivered using an Octet-stream representation. Thereby you get in the beginning some 2 integers that give the information about the dimensions of the grid and the average distance, and then followed by a float array that gives the elevation of each point. Yeah, there's also an example for this, but it looks the same as the last one. More interesting is that you can also obtain textures to this 3D model. So there is another API, which is the WMS, so the Web Map Service, to retrieve texture data for this elevation model. This finally looks like this. I would just skip the live demo as it is the same client as the last one. You can get more information about the GIS Data Provider GE in the FIWARE wiki, and it's available in the catalog. And there are also blueprints and bundles available that contain this. As we are now on the web, we need to talk about how to optimize this geospatial data for the web. So on the left, you see the Earth as a perfect sphere, and the respective coordinate reference system. So the coordinates here are the usual latitude-longitude pair. But then for any mapping service like OpenStreetMap or Google, there is the spherical Mercator projection applied, which is the second one, to retrieve squared or the Earth as a squared projection. And finally, they built a pyramid on top of this to have different resolutions of those levels of detail. And then there is some tile indexing scheme applied, so that on one LOD, one tile is on this next LOD 4 tiles. And there is some standard from the OGC as well, which is the tile map service standard, how to index those stuff. But nobody uses this standard. So Google does it the other way around. So they mirror the y-axis. OpenStreetMap does it in the same way. And well, Bing Maps is usually crap as all. Okay, but what we see here are 2D map tiles, right? They're just images. What we want to have are 3D map tiles. So there is the 3D map tiles SE available that provides, as the name says, 3D map tiles. So this is a usual 2D map tile. If you recognize, this should be the building we are currently in. I retrieved this morning and figured it out. How to bring this to 3D? First of all, we can just apply a perspective projection, but yeah, well, that's already gives a 3D impression, but it's not that sophisticated. But when we add, for instance, buildings on top of it, it gets much more interesting. So the 3D map tiles is a REST web service that is based on the OpenStreetMap's tile indexing scheme. So it adopts the usual way it is done. And it provides XML 3D, so 3D UI GE compatible geometry for each map tile. It utilizes several backends, such as an OpenStreetMap tile rendering server. As seen here, it's just a texture on the ground using a quad consisting of 2 triangles. Or other geo-information systems, such as the GIS Data Provider GE, that can be used. There is an That I might showcase. So I just used the resource provided on the slide. So it's the 16th LOD, that's the X coordinate and that's the Y coordinate, and it gives us, as we learned this morning, an XML 3D element with two models, one representing the plane and one representing the buildings. They, in turn, reference to another XML file, which is has this dash asset suffix. Was a mistyping, was it? There's a dot missing. Well, and in this asset file, we get all those elements we learned 2 sessions ago about these data things. There are meshes that contain data. So we deliver the contour of those buildings, apply an XFlow compute operator to do this extrusion of the buildings and also the tessellation that happens completely on the client. So we just deliver this 2D contour of the buildings. So there are some more demos available, like, where is it? Like this one. So that's the campus Saarbrücken, for instance, and that's the building of DFKI, for instance. So we have a very short way to our canteen, as you can see on this map. And the POIs here are retrieved from the Overpass API of OpenStreetMap and put in there. We can reload this, but you already saw it at the edge that this is loaded as tiles, and as the connection is not that good, here are 2 tiles missing and a few more here. There is another demo. So this one used the 3D map tiles and the 3D UI GE for the rendering, and has this integration with the POIs. There is another that visualizes this part of the city of Oulu, and this might take a little bit longer to load. Because we query the as a backend service the GIS Data Provider GE and retrieve from there the building footprints, as we already saw with the OpenStreetMap backend, but also the aerial imaging is retrieved from this GIS Data Provider GE to texture the ground. To address the comment of the mobile apps, so the same runs on the Android phone using usual Chrome. Yeah. So the 3D, in fact, the 3D UI GE is compatible with mobiles. It can be used in with the usual web browser, but can also be embedded into HTML5 apps. We have another one that is the it's called the FI Content Catalog app that collects some of those demos, and that's in fact a native app containing those 3D UI GE parts of this demo. And as we are now talking about apps, there is another enabler which does some app generation for you. So the pitch of that, don't know whether the, is that you have an idea. Here it was to do a marathon, so a marathon between bars in Munich. So you take a usual runner app, do some clicks to configure this, and at the end it is generated, and you can download it for Android and iOS if you select both. There is this platform, Design My App, where you have those templates and then can use this or select the appropriate template for your ID and then generate your own app using this portal. As I'm supposed to talk about augmented reality in this session, so there is this augmented reality GE available. So augmented reality is usually to overlay a video feed with extra information, like icons or textual information and so on. There's some industry uses, so like maintenance instruction, using some glasses to overlay this. But the FIWARE Augmented Reality GE focus on what's feasible on the web. So it provides a high-level API for HTML5 AR applications, and is based on JavaScript. So no plugins are required to use this. It's available on GitHub, but also part of the FIWARE releases, and the documentation is available in the FIWARE wiki. This GE consists of 4 APIs, which is the sensor API, the AR API, and the scene and connection API. I just picked 2 of them. For instance, the sensor API provides the list of available sensors within a device, like the device orientation sensor and the geolocation and the accelerator and the gyroscopes and so on. And you can interact with those sensors using the sensor API. And the AR API, which allows to register and find markers in a video stream. We already saw this jumping teapot this morning as one of the examples. When we are in the field of augmented reality, then we will not end here to just overlay the reality. We would like to make the transition seamlessly. That's why there is the group of reality mixer enablers to make the transition between physical objects and virtual objects in the scene seamlessly. Let me just okay. So we have this physical sphere and 3 virtual objects, and when changing the lighting conditions, so of the physical environmental lighting, the same lighting is applied to the virtual objects as well. That would be the next one. Yeah, so the ARGE only supports this specific type of fiducial markers. But as this might not be sufficient for some use cases, but there are also very early limits on the web due to the performance of JavaScript. We developed some additional tracking enablers on top of this ARGE. For instance, the fast feature tracking SE that does blob detection. So you just need a single colored blob that is then tracked within the video stream. And there is also a live demo. This one. So the video stream is running in the background, and the actual tracking is done on top of this video stream, and the rendering. So there is this a black dot on the wall that is used to put this wormhole on top of it, and then having some spaceships appearing from that. That would be another kind of tracking. More advanced tracking technologies like the natural feature tracking is unfortunately not yet possible using JavaScript. That's simply not fast enough. We had some implementation use cases and ended up at around 1 to 2 frames, and that's far too less to do actual natural feature tracking on the web.
Yep. Sorry, sometimes you only want to identify whatever image you have in front, so it's not really tracking. So it's only the pattern recognition to identify a building or whatever you have.
Can you please repeat the question?
So
with the mic.
I think the mic is gone. just speak up.
well, no, maybe you can repeat the question. No, my point is that sometimes you don't really need to track so everything moves. You just want the first step just to identify whatever you are looking at, and that's enough. And in that case, you don't need the tracking option. So you don't need the requirements you are saying, like for JavaScript, maybe it's too slow. You only need to identify. So pattern recognition pure, and you have a couple of seconds to do that even. So.
This would work, but was not the focus of this enablers, because we targeting this real-time use cases. What you're looking for is just identifying the QR code, for instance, or any other kind of structured marker that contain then information like a URL. But there are already a lot of libraries available, for instance, for QR codes. Okay. To summarize, we have 3D cities on the web. We saw several demos. One I missed because the display is pretty small. We have a POI look around demo where you use the device orientation sensor to look around. I can showcase if somebody is interested in the lunch break. We presented in the last 2 sessions around 10 enablers, and the materials will, after the lunch break, be available under this link where I will upload them. Now it's the time for any kind of questions on any enabler we heard about. There is the mic coming.
If we are interested in points of interest for our application, but we don't want or don't need to use user interface and 3D, should we use that point of interest storage, or should we use other generic enabler for that?
The POI storage is a specific enabler because it addresses some special needs. What I suggest for your use case is the POI Data Provider GE, which is right below that, where you can store and retrieve POI data within the FIWARE cloud. There's also an image available for this on the FIWARE lab, so you can easily set up your own instance.
And that one, and the lower one, is independently from the graphical interface and 3D?
Sure. It just delivers JSON using the presented API. But it's part of the WebUI chapter and thereby considered for this whole concept of then visualizing them. But there is one example from the use case project, FI Content. They do some GNOME Trader citywide game where they have the 20-minute box, that's newspaper, and use them for tracking in their mobile client. They for instance, do not rely on the 3D UIG. They use Unity for the tracking because it's much more faster on mobile devices. And they use the POI Data Provider GE to store their application data. For instance, the GNOME has that much peas and nuts as resources and sells for this price, so it's a trading game. Any other question?
The POI, all these POIs are outdoors. For indoors, POI?
Not necessarily. For indoors, it's just a matter of how to determine your own position. The POI Data Provider, the format of the POI Data Provider GE foresees to have relations between POIs. So for instance, you have a POI for the university, you have a child POI for this room, and for some others as well. And this relationship is contained both in the parent and in the child, so you can retrieve the relations, but then you still have the positioning issue that could be solved using then markers. So like having a QR code at the entrance, and Frankfurt Airport, for instance, does this. They have QR codes everywhere. You scan this with a specific app of the airport, and then it says, oh, you are here. And you want to Terminal 2, you have to take the SkyTrain and so on. But in fact, the POIs can also be inside. There is no issue with that. Any other question? Otherwise, we will be here this afternoon to answer any further questions. Thanks for your attention, and I think now it's lunch break.